multiplying a polynomial by a monomial. So we've added and subtracted, and now we're going to get into our multiplication. So to multiply a polynomial by a monomial, we're going to use the distributive property to multiply this. And as we work through this, we really want to pay attention to how this looks, because this distributive property is going to come back to us as we get into more complicated expressions and more complicated equations that we're solving. So let's take a look at how we work this. Our first product that we're going to find, we're going to do x times 5x plus x squared. So this is absolutely our distributive property here. I'm really just taking my x and I am distributing it onto everything that's inside the parentheses. But how I can write that out? So I've got my x, and I need to multiply that by 5x, and I'm going to add that to the x times the x squared. So notice what I have here. I have the x in both of those times each of the terms in the binomial here. X times 5x is 5x squared, and x times x squared is x cubed. So this is what we end up as our product. Next one, 3y, and then in parentheses, negative 4x minus 6x cubed minus 2y. So again, I'm going to distribute this, and I've written it out kind of the long way here. As you get comfortable with it, you're not going to do that. Feel free to do it in your head, just like we do with distributive property, normally with our constants. But I want you to see it, because again, this is going to come back very shortly. So we've got our 3y times our negative 4x, which is negative 12xy. We've got our 3y times our negative 6x cubed, which is negative 18x cubed y. And we have our 3y times our negative 2y, which is negative 6y squared. So again, I have three terms there. I've distributed my 3y onto each of the terms, again paying attention to those signs. Okay, so that 3y is now part of, since I multiplied each of those 3y's is technically a factor of each of these. Each of these has a 3y as part of it. All right, let's continue, and we're going to simplify. So let's look at some expressions that are a little more complicated, or have a few more terms to them that we have to incorporate into the final, our final simplified expression. So x, and then in parentheses, 3x minus 4 minus 5x. So here's my parentheses. Just like with our normal expressions, order of operations, we want to work with that first, our parentheses. So I end up with x times 3x is 3x squared. X times minus 4 gives me minus 4x. And then the minus 5x hangs at the end here. From here, we want to make sure we've combined like terms. I have a negative 4x and a negative 5x that I can put together. So I end up with a negative 9x. So my final product here, my final simplified expression, 3x squared minus 9x. So applying a distributive, but then also making sure that we combine any terms that are alike. And our last one that we have here, 4n, and then in parentheses, 3n squared plus n minus 4, minus n, and then a second set of parentheses, 3 minus n. So we're going to distribute here. The 4n gets distributed amongst everything in this parentheses. 4n times 3n squared gives me 12n cubed. 4 times my n gives me 4n squared. And 4n times my negative 4 gives me negative 16n. So using those rules of adding as opposed to multiplying. So when I'm multiplying here, this n times this n cubed n squared becomes n cubed. I'm also going to distribute this minus n here, which again is like a minus 1n. So that negative 1 is attached to the n. Please remember that. We don't just lose that negative 1 and kind of leave it hanging there. So negative 1n times 3 gives me negative 3n. And my negative 1n times my negative n gives me a positive n squared. We want to take a look and make sure there are not any terms that I can combine, but there are. So I have 12n cubed. There's no other n cubes, so that stays by itself. I have 4n squared. Here's an n squared down here. That's 1n squared, so that gives me 5n squared. And then I have a negative 16n and a negative 3n, so altogether that gives me negative 19n. So we're multiplying a monomial by a polynomial. We are going to distribute that monomial over each term in the polynomial. Make sure when you're working with expressions that you finish by combining all like terms.